right, this is the vocabulary you should have learned doing your assignment last time. First and main vocabulary word we learned on your assignment from last time was net, which is a two-dimensional shape that folds into a 3D figure. Okay, here's some other words you should be aware of. There's polyhedron. A polyhedron is a 3D shape whose faces, we're going to learn what face means in a minute, are polygons. So what if the face of a three-dimensional shape is a circle instead? Is that a polyhedron? No, because a circle is not a polygon. So a polyhedron would just be the shapes where the sides are polygons, like squares and rectangles and triangles and possibly even hexagons, pentagons, octagons, stuff like that, okay? Those are all polyhedrons, okay? Polyhedrons are part of solids. Solids includes shapes that are circular, spheres, cylinders, cones. But spheres, cylinders, and cones are not considered polyhedrons because they don't have all of their sides polygons like polyhedrons do. Okay? In polyhedrons, we have three things that make up polyhedrons. The main part of polyhedrons are the faces. The faces of a polyhedron are the flat surfaces. Those are the polygons that make our polyhedron. Edges. What do you think edges are? Perfect. Jason used the word meet, so I'm going to put that there. Where two faces meet, but what are some other words that we usually use in geometry that means meet? Intersect. Perfect. Okay, and then vertices is the last part we want to talk about. And what's the definition for vertices? Does anybody know? Jason knows again, but does someone else know? Okay, go ahead, Jason. Yeah, so the vertices are where the edges meet, isn't it? Aren't edges kind of like lines along where two pieces? Here's an example. So here's a cube. The faces of my cube are actually hollow. The edges of my cube have magnets in them to stick them together. And so that's along the edges where it's kind of the shape of a line. And then the vertices are the corners where all the edges meet, okay? Corners where edges intersect. And Jason mentioned that it's usually going to be like 3 intersecting points. I don't know if that's always true, but it might be. Because see, like this cube has 3, right? I hadn't thought about that before. So 3 intersecting lines, 3 intersecting edges for each vertex. Vertices is plural for vertex, right? So the vertices are the corners where the edges intersect, and 1 is a vertex. So we're just making sure we understand that vocabulary. Okay, so that's some of the vocabulary that you might have understood from last time from doing the assignments. Okay, now we need to move on with new stuff. We're going to learn about the names of some of these solids. First of all, only 2 of the solids on your notes are polyhedrons. Which 2? Prisms are polyhedrons. Good. Pyramids are polyhedrons. Okay? Because they are made of polygons. And then there's cylinders and cones and spheres. Okay, let's define each one of these. A prism, just make sure I'm following along with mean, I know what it is. I just wanted to see if I had follow along and don't botch up the definitions. Okay. A prism is the definition of a prism. I'm just going to write the definitions on the front here. Okay. If you don't want to write on the front of this, you want to leave it all pretty. We have other stuff we need to write inside. Just write it on the front or a separate piece of paper. Okay. All right. So this is a prism. A prism is two congruent polygons connected by rectangles. Two congruent polygons connected by rectangles. And it's named for the shape of the polygons. Named for shape of polygon. Okay. So this one is kind of weird because all of the faces are rectangles. So that means that the two congruent polygons could be considered any of the two opposite sides. Like we could say it's this end and then the end over here that we can't see because of the perspective. Or it could be the top of the box and the bottom of the box. Or it could be the front and the back. It doesn't matter which ones we are considering the polygons in this particular case because they're all rectangular, okay? So because of that, this particular shape is called a rectangular prism. A rectangular prism is what we would call that one. Now on the inside, we're going to be finding the surface area of a rectangular prism. So I just wanted to look at that picture really fast first. Does this fit the definition of a prism? Let's look at the definition of a prism. Two congruent polygons connected by rectangles. Two congruent polygons connected by rectangles. Does that look like that fits the definition? Yeah, but we wouldn't call this one a rectangular prism. What would we call this one? This one's a triangular prism because the bases are polygons. Are triangles. Bases are triangles. Okay. To need that, we'll come back to the inside later when we're actually learning surface area. Okay, a cylinder is a lot like a prism, isn't it? Isn't a cylinder kind of like a prism? Have you guys ever taken a can or some sort of cylinder? I should have brought like a paper towel tube or something like that. If you ever take like something that's cylinder, this one isn't quite cylinder because it kind of gradually goes outward, right? But if I were to take an actual cylinder and cut it down the side like a paper towel tube or something, and then open it up, what shape would I have? A rectangle and then two circles for the top and the bottom, right? So imagine that you have some sort of cylinder, you cut it down the side so that you can see the shape of this outside piece, and it's a rectangular shape, isn't it? So a cylinder is kind of two circles connected by a rectangle, isn't it? It just happens to be one big rectangle that connects those two circles together. So it's still sort of like a prism. We don't call it a prism, but it's very similar to a prism. Okay. A pyramid has a very specific definition. We're not going to actually define cylinder. It's just, I don't know, you could say it's like a circular prism if you wanted to write something down. Or you can look up your definition in the book so you have something more official if you want. Okay, a pyramid. A pyramid, instead of having two bases, this time it only has what? One base. Okay, so it has one polygon base and triangular sides. Or I'll just say sides are triangles. You can have all sorts of different shaped pyramids. This one is kind of a square pyramid, don't you think? I'm pretty sure this is a square, so we'll call this a square pyramid. It's possible that it's a rectangle instead of a square, but a square actually is a rectangle, so maybe a rectangle would be a better word to use because we don't know for sure if it's the same dimensions. Okay? But you can have triangular pyramids where the bottom of it is a triangle. You can have hexagonal pyramids where the bottom of it is a hexagon. It could be any polygon shape, and then the sides come up and meet at the top with triangles. Okay? So you have one polygon base and the sides are triangles. Okay. And then is a cone sort of like a circular pyramid? Yeah, if you were to cut this and unfold it, that would be kind of a strange shape, honestly, around, but it would be sort of triangular. A sphere is in a class all by itself, because a sphere really doesn't have any faces. It's all just one big surface. There's no polygons on the outside of it. So, anyway, I just wanted to make sure we had the definitions for prisms and pyramids, because those are the important ones to, well, they're all important, but those two in particular have specific names that go with them, okay? That I just wanted to make sure you understood those. Okay, I'm trying to figure out how far we should go today because of our time. I'm going to go ahead and stop.